Okay, now we're going to look at the insertAfter function, which is very similar to the removeAfter function. And the insertAfter is going to have a similar behavior as removeAfter in that if we want to insert something at the head, we're going to use a null pointer to indicate that fact. And because it's easy to insert after a pointer, not before, then we're always going to be giving an iterator that lets us insert right after that iterator. So there are, these three similar cases again as removeAfter. We might want to insert at the end of a list, so we could pass in an iterator to the tail and then append something to the list. By doing that, we could insert a node in the middle of the list, or we could insert before the head by passing in a null pointer. And in the chance that our list is null, and we use this function to insert into a null list, then we need to update both the head and tail pointer in that case. So I'm going to go through a few examples of this. And so the steps here run down the slide on each side of the slide. So let's say I want to append something to the tail of my list. Then my iterator is going to point at the current tail, and I'm going to add a new node onto the end. So in this case, let's say I'm adding on bread. So I'll pass in iterator pointing to eggs, and I'll pass in the data for bread, and I'll make a new list node that's initialized with the string bread. And then I need to bring this into my list. So there are two things I need to do. I need to make eggs point at bread, and I need to update the tail to point at bread. And so I can make eggs point at bread by saying, it.node arrow next is equal to this new node. And so that establishes this link. And then I can say if the tail is equal to the current iterator, then set the tail equal to node. Now, by making this a conditional, it allows me to also handle the case. It allows me to partially handle the case of inserting in the middle of a list. The only other thing I might need to do to make inserting the middle of the list work is when I insert this node in the middle, I'm going to have to connect it to whatever's on the other side of eggs. So that's a little extra condition that would have to be here. Okay, and then over here on the right side of the slide, I'm showing the situation of inserting at the inserting at the head of the list. So the iterator is null, and when I create this new node, I'm just drawing over here just for convenience. So I have this new node, and then what I need to do is set head equal to node, and set its next pointer equal to the current head. And you'll note that I can actually achieve setting the next pointer using the constructor of the list node object. So I just pass in the current head value as the second parameter to list node, and that sets its next pointer to point to the milk. And then I just need to redirect head to point to bread, and then my list is formed. Now it's kind of drawn out of order here, but if you follow the head pointer, head goes to bread, and then its next pointer goes to milk, and then its next pointer goes to eggs, and then its next pointer goes to null. So that's the order that we wanted, and we achieved that. And then as the very last step, we set head equal to node to create that final link. Okay, so this code, it looks like this. The insertAfter function takes an iterator and an item. And note the pseudocode, and this should say 4.3, not 11.3. I apologize for that. And so there are a couple of cases we need to detect. If the iterator is a null value, then this is the special case where we inserted the head. So when we allocate the list node object, we pass in the head pointer to indicate that we should go ahead and initialize its next pointer to be the head, right, to point to the head. And then if the head is null, then we set head and tail equal to this node, because that means it's the only thing that's going to be in the list, and we need to set both head and tail to point to this node. But if head is not null, then that means there's lots of things in the list already. I don't need to change the tail. And I just need to update head to point to the node. Okay, so that's the case of the iterator being null, and I'm inserting at the head. I'm either inserting in an empty list or a list with at least one thing. Okay, else I'm inserting in the middle of the list or I'm inserting at the tail of the list. And this actually turns out to be pretty simple. So I make a new list node, and using a similar trick, when I allocate it, I go ahead and I give it the next pointer of the node I'm pointing to. Now, if there's actually something there, then it's going to be pointing to that node. But if there's nothing there because it's the tail, then that's going to be a null pointer, and I'll be initializing this node to have a null pointer, which would be what I need to have happen if it's the tail of the list. Okay, and then I update the next field of the node that we're inserting after to point to this new node. And then if it's the case that the tail used to be pointing at the iterator node, then I update tail to point at my new node because now it's the last one. Okay, and that takes care of, the case of inserting at the middle or the tail. Okay, so in summary, we have a fully general iterator-based insert operation. It can insert at the head, tail, or the middle of the list. Because it's iterator-based, the client doesn't need to understand how to update the list, right? It just needs to say where it wants to make the update to the list, and then the internals of the list object does that for us. We do need a special case to insert before the head because no node is before it. There's no way to say after something that doesn't exist, but we can handle this with a special case of using a null iterator to just say, oh, the node we want to insert should come at the beginning of the list. Can we keep using an iterator object to traverse a list if we pass it to insertAfter? So insertAfter will insert something after the iterator, leaving that current object intact. So if I insert after an iterator and then say next on that iterator, I'll go to the new object. So the answer is yes, I can do it. Okay, just don't try to iterate using a null iterator. If I insert after a null iterator, then it's still going to be null. And it's not going to work after that point. Or at least you can't use it to find the next node.